In this video, we're going to look at regular expressions in Python. Regular expressions are just formalized methods that we can use to search through a string of information in search of certain patterns. If we want to use regular expressions, then we need to import the regular expressions library. And to do that, we just use the Python import feature. And the name of the library that we are importing is just abbreviated to RE for regular expressions. We are not going to use it, but to illustrate, there are many other libraries that are available in Python. And one of the more common ones is the math library. So here I just show you that you can use the import to import the math library to get mathematical functions like sine, square root, cosine, and things like that. But we're not going to use it in the following examples. Well, let's look into these regular expressions then and just do it by example. So the first thing we're going to do is to just look at a search method that we can use to find a pattern in a string. So we're going to use this thing called a search method. And here in the comments I've explained how we can use it. Whenever you want to use one of the methods that is a part of the library, then we want to prefix that function with the name of the library. And we do the same thing with math functions. We would do math.sine or math.square-root. In this case, we're using the regular expression library, RE, and we're using the search method from that library. The search method is going to take two arguments. One is going to be the pattern that we're looking for, and the second argument is going to be the string that contains that pattern. Now, for example, if we wanted to find the pattern GAAT in a string that we have identified with the variable DNA, then we would use the following. We would do regular expression.search, and then the pattern shows up first in double quotes, comma, and then the string that we're searching through shows up here. All right, so now let's actually write, instead of using comments, let's actually look at the Python code to do that. And I've declared a small segment of DNA here, and I've set that to the variable DNA. Now, we're just going to use the if statement in order to search through the string, looking for the substring, and the result is going to be either true or false. So here is the if statement. So the regular expression search, this thing here, that returns a value that can be interpreted as true or false. Now, in the next video, we're going to look at more detail about what really comes back, because it's more than just T or F. There is a structure that comes back that we can use to find out more about what was found when we did the search. So we'll see that coming up. Now, in this case, we just have if search substring GAAT within string DNA. Now, if that string really is in there, then the if statement will be true, and we'll print out GAAT is found in string DNA. Well, is it in there? Well, if we look at the string DNA, we do see GAAT is inside the string. So this certainly should return the value true, and it should print out this print statement. So let's go ahead and run our program, and let's see if we get that result. So when we look at the output, then we do get that string printed, that output printed to the screen. GAAT is found in string DNA. So the search method then does return true because we did have that substring within that pattern within our total string here. So we can use the search method in order to find these substrings within a larger string. Before we go any further, I need to tell you what a raw string is. So let's look at an ordinary print statement where we will print out something to the screen. And you can see here the same thing we've used many times before. We just have a double quote, and then we have some output, and interspersed we have some backslash ends that will send us to a new line. So these backslash characters, those are characters that we have seen earlier that don't really get printed to the screen. those are called escape characters, and they tell us how to format the output. So in this case, this print statement would print out 3 different lines with line 1, line 2, and line 3 on each of the 3 lines. Now, a raw string is a little bit different. So let's look at what a raw string would look like. So let's paste that in here. So I'm going to print out raw string, and then I'm going to have the exact same print statement, but I'm going to have the little letter R preceding it. So the R is outside of the double quotes. So that means that this thing here is what we call a raw string. Then if we have a raw string, every character prints to the screen. That is, this \n will not be interpreted as a line feed. It'll actually print out the / character followed by the letter N. So with a raw string, we do not allow any special characters for formatting. Any special character can show up in that line. And that's important when we're trying to search for strings, or when we're trying to search for patterns in strings where those patterns may have special characters, like a / or a £sign or an exclamation point. All right, so that is what a raw string is. So just remember that. Raw string means that every character you see here will be printed to the screen. It will not be considered as some kind of special formatting embedded within there. So let's print this out or run the program and see how these 2 different lines are printed. So we'll look at the output. So when we bring this over, then you'll see that the print statement, the first one, we print out 3 lines. We print out line 1, line 2, line 3. And in that instance, when we had this print statement here, the \n caused us to go to a new line. So that was the formatting. Now in the second case, we interpreted this whole thing as a raw string. So when we do the print statement, it actually prints out the \n. So a raw string then is going to let us search for special characters, which will be important. And those characters, are not going to be interpreted as formatting characters. All right, now let's move on and look at the next example. So let's start just by searching for a simple pattern in a string. Okay, so we kind of did that up here already, but we'll do it again here. And in this case, we're going to use a raw string instead of just a regular string here. As it turns out, regular strings would probably work just fine for all of our examples because we're not really looking at any special characters embedded within our list of DNA bases. But at any rate, let's follow the technique here. So the first thing we'll do, and I'm just going to call that example 1, is we're going to search for a pattern within a string. And if you happen to have the book by Martin and called Python for Biologists, this example comes from page 155. Okay, so it's a short little example. Let's just go ahead and paste it in. And all of these are going to be if statements. So I'm going to set up a string of DNA here. Then I am going to use the raw string this time to do the search. Okay, now once again, if I left off the R, it wouldn't make any difference because there aren't any special characters in here that I need to worry about. But to be generic and use the most general form of our search, we need to make sure that the strings that we're searching are actually what we call raw strings. So if we find the substring GAATTC, if we find that pattern inside our DNA, then we will print out the restriction site is found. Okay, well, let's look at that line. Let's see if we can find it in there. Okay, so here's G, A, A, T, T, and C. So yeah, sure enough, this pattern is in our DNA string up there. So this should print out that restriction site has been found. So let's run the program. And so now we can bring over the output. And for example, number 1, we do see that it detected the restriction site. And so this turns out to be true. The search for the raw string GAATTC within the longer string DNA is true. We found this pattern inside the longer string DNA. All right, so that's a pretty powerful thing. So we can find patterns within longer strings very easily like this. Now, you might be remembering that we did something similar with the find method a while back. And the find method works as well, but you're going to see shortly that the search method has a lot more power than the find method did. Now, let's continue with another example. And this is going to be example number 2. So let's take a look at it. Okay, so I'm going to copy and paste the code down here. And this is called alternation. And again, if you happen to have the book by Martin, then it's on page 156. So let's move that up a little bit. This is example number 2. All right, so in this case, I've got 2 different strands of DNA that I want to use. And by the way, my variation here is going to be a little bit different than the one that's in the book. So I'm adding on to it just a little bit. So they used only one example DNA, and I'm using 2. Now, let's look at a search for a pattern. So let's go ahead and copy what we want to do and put it here. And what I want to do this time is I want to look for the letters GG followed by either an A or a T, and then that followed by CC. So that means I could be looking for GGACC or GGTCC. So this search will find both of those possibilities. Now, here's how we write that. We use the search method, and again, we're going to be using raw strings all the time now. And you can see we're starting to use special characters in here. Okay, so that's the bar. Then that's over. It's an uppercase backward slash on your keyboard, and that's going to be able to give us what we call an alternation, one or another. So the syntax of this thing is saying we want to look for the pattern GG, and then we have parentheses here. Then after the double G, we want to look for an A or we want to look for a T. Afterwards, we want to find the letters CC. So in order to match that, let's look at the first one here, just the DNA. Do we have a GG up there? And that's why I added DNA 2. There is no GG together. Okay, so in the regular DNA, this is not going to find the restriction site, so that would be false. But we'll run it and see. In the second case, when I'm looking for DNA 2, which I'll go ahead and put that in. Let me just do the if statement. So I'm going to do a search on both of those. Okay, so now we're looking at DNA 2, but it's the same if statement. So in DNA 2, do we have a GG? Okay, yes, there's one. Is it followed by an A? Yes, it is. Then after that, do we have CC? And yes, we do. So this would be true. Now, not only that, but we also have a GG here, followed by a T, followed by a CC. So that would also match. That pattern would also match the longer string DNA 2. So when I run this, example number 2, then we're going to print out this one. We found the restriction site in DNA 2, but it will not print out that one because that will be false. So now let's go ahead and run the program and look at the output that we get. Okay, so we'll bring that right over here. And in example number 2, then you can see what I just said. Okay, so in example number 2, we only print out in DNA 2 the restriction site is found. This first one, this turned out to be false, so we did not print out this statement here. So you can see now that we're gradually building up our capability to search for strings where we have different things that we might want. So this finds the GGACC and it finds the GGTCC. So that's called an alternating pattern. Now let's look at character groups. What on earth are character groups? Well, character groups, believe it or not, they're groups of characters. So we're going to be able to search for a group of characters that's within a pattern, and then that whole pattern is to be searched for within a string of some sort. So this will be example number 3. I'm going to declare a couple of variables with different DNA bases. So let's put a DNA and DNA 3 in here. Okay, so I think the DNA is the same as the one up above, but DNA 3 looks a little bit different. Now, what I want to do is I want to set up a search. Okay, I want to search for a certain pattern. So I want to search for a GC followed by either an A or a T or a G or a C. Okay, so I'm looking for GC followed by any of these four characters, A, T, G, or C. Then after that, we need to have another GC. All right, so let's look at DNA 3 and let's see if we can find that. So we have several right here. Right here's a GC, and that's followed by a G, so that would work. We have a GC over here, that's followed by an A, so that would work too. And regular DNA, we have the same thing. Okay, we have a GC followed by a G. So what this will do is to allow us to find the string or the pattern GC followed by just one of either an A, a T, a G, or a C, one of those, and then a GC next. So if we did that alternation up here, then we could just expand the alternation and do the same thing down here. So here's one way we could do it. So I'll put the if statement down here, and I'll give us some space so we can move up. So we could write it like this. We can just extend what we did up here with A or T, and we can make it A or T or G or C. All right, so we're looking for GC followed by one of those other bases, followed by GC again. Now, let's go ahead and run the program, and let's look at the output that we get. So I'll click Run, and it wants me to save it, of course. And then you see the output show up. And under example 3, which we're doing, then you can see that in DNA the restriction site was found. Okay, so that comes from right here. So now we are looking for any one of these four letters that appear between a GC and a GC. There happens to be a shortcut way that we can do that. So let's look at how we can shorten the way we write that, even though it's really not that large, is it? But we can make it even shorter. So here is another syntactical approach that we can use. We can use square brackets and close it with a square bracket. And we can put a list of characters inside those. And what that will do is to allow us to match any one of that group of characters that we put in there. So it's a little bit shorter. And here's how you would write that. Okay, so instead of using the parentheses with the bars that we used up here, we can use the square brackets and then just put all the letters that we're searching for within the square brackets. And now, once again, it's not looking for all four of them. Okay, it's just looking for any one of that group. So one A, one T, one G, or one C. And if that's true, then we'll print out that the restriction site was found again in the DNA 3. Let's add another if statement that will also search for the pattern within our string DNA. So we have two if statements here. One will search through the string that's in DNA 3, and the other one is in DNA. Okay, so those were defined. Where are they? Right there. All right. So let's see what we get when we run the program now. And we're continuing with example number 3. So we'll run this program, and we'll look at the output that we get. And you can see that we get both of these as true, right? So where were we here? In DNA 3, the restriction site was found. Okay, so that was where we get one of those. And down here, we got in DNA 3, the restriction site was found. Okay, so that was output. But we didn't print out the one where we just found it in the DNA variable. So it didn't show up there. And let's see if we can find out why. So let's look back at regular DNA. So we need a GC, and here is a GC right there. Then that's followed by either an A, T, G, or C. Well, okay, it is. It's followed by a G, so far so good. But afterwards, there is no GC in our variable DNA. Okay, so there's no GC that follows this, where is it here, GC with an A, but then there's no GC down here. So the whole thing turns out to be false. So you have to match the pattern exactly in order for this to work. But you can see now that we're getting more flexibility in the way we set up the patterns that we're searching for. And we'll continue in the next few examples to see that. Now we can look at another special character that we're using, and we can use a dot, that's a period, to match any character whatsoever. So here's example number 4, and let's see how we can use that dot to look for the same sequence that we just did in example 3. So in this case, our search method is going to look for GC followed by any character. Now, the disadvantage here is it doesn't have to be an A, T, G, or C. It could be an X, it could be the number 7, it could be anything, a question mark. So when you use the dot, that matches one and exactly one character. We know that in our string, then we only have A, T, C, and G's. We'll only have those, so we'll be okay. But we can use dot to match one character, so this will also give us the same result. The other thing, though, is we can use multiple dots if we want to. So let's look at another if statement. So let's drop one of those here. And in this case, I want to match 3 characters. So let's look for the pattern AT and then 3 characters, and it doesn't matter what they are, followed by a GC. So each dot represents one character, which can be anything. So I'm looking for AT, any 3 characters, followed by GC. So let's run the program and let's see if we find anything that matches. So the output now pops up, and we're in example 4. So we see in example 4 that sure enough in DNA 3 the restriction site is found. So we see that here. And we also see that the pattern AT 3 characters was also found. So let's look for that in DNA 3. So you see that we did in the first one here in DNA 3 where we had just a single dot, we found that. So let's look up at DNA 3. So here we have GC there, followed by a character, which is A, followed by GC. All right, so that's the same thing we looked at earlier. Now, how about 3 characters? Okay, we'll start with AT, which is at the beginning, right? We have AT, then any 3 characters. So we have C, G, and C. So it could have been any other 3, but we have 3 dots there. Then followed by GC, so that matches as well. So both of these will be true, and we can find both of those patterns using our search method. Now let's look at quantifiers. So quantifiers are discussed on pages 157, 158. And what are those things? Well, all of the examples that we looked at above, they match one and only one character. So we have to have a dot that matches one character, or if we have the OR notation up here, then the alternation that matches only one character. But what if we want to match any number of appearances? Well, how about 0 or 1 to begin with? We can use the question mark, and that will match a 0 occurrence or 1. So it could be there, or if it is there, there's only one of them. So now let's look at an example for that. Okay, so we'll put the code here. This is example 5, and the DNA sequence will be shown here. And what I want to do is do a search. Okay, so the pattern I'm looking for is AAGTT or just AATT. So the G could be there or the G could be missing. And we can use our search method to set up a search for that. And the way we do it is to use the question mark. So let's put the if statement in here. And the pattern looks like this. We have the letter G followed by a question mark. So that means we could have 0 or 1 G's that show up. Now, if we use the question mark after the T, we could have 0 or 1 T's that show up. So the question mark means 0 or 1 of the preceding character. So this will match AAGTT or AATT. So that works. And we can use this question mark as many times as we want throughout this. So we can make a more complex pattern if we wanted to. Now let's go ahead and let's run the program, and we'll see that that really does work. So in example number 5, then you can see sure enough, we found something. We found AAGTT within our DNA sequence. And in our DNA sequence, which one did we find? Well, we found the AATT, so 0 G's in that case. So it matched this pattern here. Now, let's look at a group of characters. So we can also use this question mark and the parentheses together. So how do you interpret this? Well, you can use a sequence of characters as well. So we can look for the pattern GGG, and we need all three of them, followed by a 0 or, wait a minute, I don't think I wrote that exactly right. We can search for GGG followed by 0 or more group of 3 A's. Well, that came out kind of cumbersome, didn't it? So we want to start by looking for 3 G's. Then inside parentheses, I've got a group of 3 A's. And after the parentheses, I've got a question mark. So that means I'm looking for 0 of these, which of course is nothing, or I'm looking for one group of them. So what that will match is GGG and TTT, or it will match GGG, AAA, and TTT. Right? So let's look at an example for that. So I've got 2 DNA strands declared, DNA1 and DNA2. And in the top one here, you'll see here's the GGG and the TTT. So there's 0 groups of 3A's there. And I guess that's the one we're going to use, DNA1. And DNA2 is not there at all. Okay, so we don't have a GGG or TTT down here, so we're not going to get anything out of DNA2. So let's run this example, and let's look at the output that we get. So I'll click the Run button. Okay, and I've got an error, so let me go fix that. Just turned out to be a tab. There was a tab down here, and it didn't like the indent, so that was what was wrong. So let's run it again. Okay, the other error I had was I had a missing right parentheses here. So anyway, now I have run the program, and we can look at the output. So from this bottom part down here, so we have example 5. So in the first one, the first pattern, we said we had the AAG question mark TT was found. So that was up here. Now, we're going to get one or the other of these down here at the bottom. So this says we found the pattern 3 G's, triple A's with a question mark and 3 T's found in DNA 1. Okay, so if we look back up here, you can see that, sure enough, there it is. Okay, 3 G's, 0 AAA's, and then 3 of these T bases here. Okay, so if we had also 3 A's in there, then we would have found that as well. So we can use the question mark to do 0 or more of a preceding group delineated by parentheses. In the next example, we're going to look for 1 or more. Okay, now notice how we're building this up. When we first did the examples up at the top, we were matching a single character. Now, in the previous example, we could match 0 or 1. Now we're going to look at how we can match 1 or more groups. So in this example, we're going to look for 3 G's followed by 1 or more A's. Right? So we write it with a plus sign. So the syntax for this would be look for 3 G's followed by 1 or more A's followed by 3 T's. So now let's look at example number 6. Let's put the actual code in here to do the test. So let's paste this in. And I've declared DNA2 as this string here. DNA1 is still the one we had up there. So let's do a couple of the search methods. And we'll look in the string DNA1 for this sequence, 3 G's followed by 1 or more A's followed by 3 T's. And we're looking for that in DNA1. Well, is it in there? If we go up here and look at DNA1, we'll see that we really do have 3 G's, we really do have 3 T's, but there's no A in between. So I think that's going to end up being false. In the second case, we'll look at DNA2. And in this search, we're looking for 3 G's followed by 1 or more A's followed by TCG. So if we look in that one, in DNA2, then we have 3 G's here. Then we have a bunch of A's. We have 5 of them. And then afterward, TCG. So the pattern should match there. Okay, so that pattern is going to be found within the string DNA2, and we're using the plus sign here to get one or more A's. So let's run the program, and we'll see what we get from example number 6. So the output pops up, and you can see in example number 6, we found it in DNA2, but we didn't find it in DNA1. So this was false, and well, the if statement was false. We didn't print out the pattern from DNA1. This one was true. We did find that pattern in DNA2, so we printed out that that pattern was found in DNA2. All right, now moving on, let's continue to look at some ways we can form these patterns. So we've seen that we can match 1, we can match 0 or 1, we can match 1 or more, and we can match 0 or more. So we have a lot of different options here. So we can do almost the same thing we just did in example 6 with the plus, where we matched 1 or more, but if we use the asterisk, that means we can match 0 or more. So in number 7, let's look at the search. We'll still use DNA1 and DNA2, and this time we're going to use almost the same pattern here, DNA1, but we're looking for 3 G's followed by, this time, 0 or more A's. That asterisk means 0 or more of the letter A. And we'll use the same thing down here in the pattern that we just did looking in DNA2. So do we find it now in DNA1? Well, if we look at DNA1, which was back up here somewhere, then sure enough, there are 3 G's, and then there's no A, so 0 or more A's would work, and then we have 3 T's. So this should match, give us a true result for both DNA1 and DNA2. So let's run it to prove that works. And in example number 7, you can see it does. So in example 7, then, we can use this asterisk to match 0 or more of the preceding letter. Okay, 0 or more A's in this case. Now, let's look at some more. We're almost done with this video, but we still have a couple of other things that we can do. And let's look at those. So let's start with this. Okay, example number 8. Remember the curly braces? Okay, we've seen those before. But let's suppose you wanted to match a specific number of something. If we wanted to look for 5 A's or 3 T's or 4 G's, then you can using that curly braces notation. And here's the way we do it. Let's make a copy of our code and let's put it in here and give ourselves some space. That's going to cause me trouble, I think, because I've indented. It doesn't like an indent. So maybe this will work. Okay, anyway, so I have declared DNA1, DNA2 here. And here is the way I would write that search. So I'm going to look for a pattern G, C, and exactly 3 G's. Then exactly 3 T's. Okay, so the T here, followed by the curly braces with a 3, that means exactly 3 letter T's. Over here, G, followed by the curly braces and 3, exactly 3 G's. So it's looking for GGG and TTT. That's what it's looking for. All right, so now let's just run this example number 8. It won't take long, and we'll see if we find it. And we do. Okay, example number 8, you can see we did find the pattern 3 G's and 3 T's in DNA1. And if we look in DNA1, then sure enough, there they are. So if you do have a very specific number, then you can use that number inside curly braces. All right, so now let's do another variation. And having seen these things in Python already, you could probably predict that you could do this. Instead of just using one number in the curly braces, you can use a range. All right, so if we wanted to look for either 1, 2, or 3 G's, then we could use 1, 3. Okay, so that works here. You can use 2, 3, 2, 5. The usual way that you can format a range in Python, you can format that in here, and that would let us match 1 G, 2 G's, or 3 G's. And over here, we still have the curly braces with 3 T's that would have to match. Okay, so would that match what we find in DNA1? I think so. We have DNA 1, we have a GCG right there, and that's followed by 1G, and that's good enough. That matches, okay? It also matches 2, and it doesn't match 3, right? But it does match 1 or 2, so we'd get a true result from this if statement. Okay, now, that's example number 8. Let's run that one, and you can look at the answer. So in number 8, you can see that we really did find a pattern of G's in the DNA sequence, DNA 1, followed by 3 T's. We're almost at the end, as I've said, so let's finish up by looking at how we can match things at the beginning or the ending of a string. So let's put that in here. We can match a string that's at the start or the ending. I should say we can match a pattern that's either at the start or the ending of a string. We can designate the start of the string with the circumflex. We can designate the end of the string with a $sign. So this is example number 9. So let's just do an example. All of these things is using the search method. And this entire video is just how you can formulate search patterns. To look for AAT at the beginning of a string, you use the circumflex over here just to the left of it. Okay, so now this is on the left-hand side. So this anchors the beginning of a string. So the beginning of the string followed by AAT. If we find that at the beginning of DNA 1, it'll be true and we'll print this out. So if we look at DNA 1, then sure enough, we have a AA and a T starting it, so that would match. If we want to match something at the end of the string, we use a $sign. So let's look at an example of that. So let's drop that in here. And if we want to look for the string ATCG at the right end of the sentence, then we put the $sign here, and it's on the right-hand side. So this means that if we find at the end of string DNA 1, A, T, C, and G, that will be true, and we'll print this out. So let's run the program, and let's see what we get. So we'll look at the output from 9, and it says, hey, sure enough, the pattern AAT was found at the start of DNA 1, and the pattern ATCG was found at the end of DNA 1. So if we look at DNA 1, then sure enough, ATCG, that's at the right-hand side. That's the end of it, so that gives us the true for that last one. And it starts with AAT, which gives us true for the first one. So now, you have seen quite a few ways that you can set up a pattern for searching within Python. So far, the only result that we've seen from these searches is either a true or false result. So we have all of these things that you can look at, and some of these are in, most of them are actually in Chapter 7 of the Martin book. I've added just a few things in to extend it. So remember the deal with the raw string. All right, once again, we didn't really have to have it in the examples I showed you, but the really the accepted technique is to always use the raw strings when you're doing these searches. And we can formulate the searches in a lot of different ways to match a lot of different patterns. And that's what this video has shown. Now we're just approaching 40 minutes. That's long enough for a video. So I'm going to close this example here.